record. Okay. Hello, my name is Matt Roebuck. I'm with Aqueous Technologies. We are a biotech group out of Boston, Massachusetts, and we've been together for almost 12 years now as a team. Today, we're going to talk about why we're different than traditional ozone generation and the initiatives and certifications and testing we've gone through for our safety concerns. There are numerous safety concerns out there with traditional ozone generation and gaseous ozone generation. However, we are a different way or approach of making ozone. We make liquid ozone in water. So today I'd like to introduce everyone to our CTO, Dr. Microbiology, Dr. Shu Simon. Dr. Shu is going to talk a little bit more about our technology when it comes to human safety. So Dr. Shu, do you want to talk a little bit first about what makes us different and unique? And then we can talk a little bit about the safety aspects.
Absolutely. Matt, thank you for the introduction. Again, my name is Shu Simon, and I'm Chief Technology Officer here at Aqueous Technologies. What Aqueous does is we provide a solution that is aqueous ozone based, and this solution kills microbes. So this is an antimicrobial solution, and the way it works is we use ozone and we put ozone into water, and that ozone kills microbes. So that's the generals of how this particular solution works. And then when people hear ozone, it often brings up the idea of the ozone layer or gaseous ozone, which is ozone in the gas. Now, most of the time, ozone is in the ozone layer, and it's way up high in the atmosphere where it's not accessible to us. But sometimes, for example, in the case of laser printers, you can experience gaseous ozone closer to the earth, and then people can breathe gaseous ozone. Aqueous ozone is completely different, and the reason is aqueous ozone is constrained in a liquid stream. So the ozone does not get into human lungs. It stays in the water, and that's important for a couple of reasons. One is you can control exactly where the ozone goes, so exactly where the ozone does its job. And the other reason that this is number two, why this is important is ozone has a very short half-life in water. And what that means is aqueous ozone goes in, it does its job, it kills its microbes, and then it disintegrates, and the ozone is no longer there. So in the gas, there's a much longer half-life, so the ozone will stay around for longer. And those are the two main reasons that aqueous ozone works completely different from gaseous ozone, and it is safe.
Great, Dr. Shu. Let's pivot and talk a little bit about some of the initiatives that we've taken in the past to ensure customer safety. Do you want to touch on some of the past testing and consultancies that have reviewed our technology?
Absolutely. So first is on aqueous ozone in general. It has a designation from the US FDA. It is a GRAS designation, and that means generally regarded as safe. And so what that means is the US FDA is not concerned about aqueous ozone because it is already known in the community to be safe. However, we have also done two other methods of testing. First, we have used an independent third-party consultant to model for us our aqueous ozone technologies, and in even heavy use, is there any possibility that using our aqueous ozone generators, would there be any possibility that you can generate high enough levels to be of a safety concern? And this was run by Toxel, independent consultants, and their models showed that no, at the levels of aqueous ozone that we make, it is not toxic to humans. So in addition to this, we have run our own experiments where we have generated aqueous ozone even inside a tiny closet to see whether we can get enough off-gassing to raise concerns. And we did not find enough off-gassing to raise concerns. So even in a small, constrained, unventilated closet, the levels of ozone that we generate are safe.
One of the clarifications I'd like to point out is that all of our products are pre-programmed to produce a certain concentration of aqueous ozone. They're never going to go above that pre-programming concentration of aqueous ozone. So there's no real way in error that our products would make 5, 10, 20 times the programmed amount of aqueous ozone. So that's one of the big reasons why we're always going to be safe for humans and human exposure. Well, great, Dr. Shu. This was a big help. Do you have any insights into Toxel? I believe that they are a OSHA approved or accredited third-party toxicology firm where they do a lot of work to OSHA standards. Can you explain a little bit about OSHA and Toxel being a prominent toxicology firm in the US?
Yes. OSHA standards are standards for occupational health and safety in the US. And the reason that there are third-party certifications or third-party studies to show compliance is because we find it very important that solutions in the workplace are safe for the humans that are in the workplace. And this third party, Toxel, mediates between what the actual solutions are. So in this case, Inozo versus the standards that have been established for safety. So they have no benefit for one or another outcome. They simply run the testing.
Great. So just to summarize and reiterate, Inozo Technologies makes aqueous ozone products. We have a technology that converts water into liquid ozone in real time or on demand. We're pre-programmed for our concentration. There is a computer board in every product. Every product we have is quote unquote smart. So we know that we're never going to make more ozone concentration than we programmed for. And then the final thing is that we make our liquid ozone in a delivery method, AKA a droplet size or a volume that's going to retain that ozone for the longest amount of time possible. And it's not going to allow a dangerous level of off-gassing to come from that liquid ozone that we've just generated. Does that all sound correct to you, Dr. Shu?
That all sounds correct. And I will also add that the reason that aqueous ozone will kill microbes and will still be safe for humans is because humans have a protective layer of skin. And by the time, even if humans do get the aqueous ozone on their skin, there are so many skin cells and it takes so long to absorb aqueous ozone through the skin that by the time anything potentially damaging gets reached, the ozone is completely dissipated. So skin is a protective layer.
Now, Dr. Shu, in light of the pandemic, you bring up a good point. For the past 18 months, 2 years, pretty much every human on this planet has been exposing their skin to alcohol-based hand sanitizers and harsh chemical sanitizers that our skin is just not meant to be exposed to. What would you say would be the benefits of aqueous ozone on your skin against high concentrations of alcohols or chemicals?
And I think that's an interesting question, especially because you said high concentrations. So the first thing I will point out is aqueous ozone is effective at very low concentrations. And the second thing I will point out is that ozone is not a sensitizer the way stable, harsh chemicals are. So putting aqueous ozone on your skin, it's just as gentle as putting water on your skin.
Great. Well, I'm sure humans around the world together are scratching their heads the last 2 years that more alcohol's been on their hands than in their stomachs. But it's the world we live in, and people are trying to stay safe and healthy. We just have a technology that can really help people do so without all the drawbacks of the alcohols or the chemicals. With that, Dr. Shu, I hope this has been educational for our customers, and I want to thank you for your time, Dr. Shu.
Thank you, Matt.
Have a great day, everyone. Bye-bye. Okay, cut. Dr. Shu, I will download this recording, send it to you and Holly, and see what we say.
Sounds good.
All right, thanks so much.
Thanks. Bye-bye.